Hey guys, how you doing? This is Coach Scott with another video on Purple Wave Chemistry. Uh, and anyway, we want to go ahead and get you guys going so you guys have what you need to do well. So let's look at relative mass. Okay, so this was one of the little activities we did earlier in this unit, in Unit 5, on counting atoms, right? And this is just another way of doing it. Then I'm going to explain using the periodic table what we're looking at here, okay? So it asks us to consider the relative mass of the various hardware below. You can see we have washers, hex nuts, anchors, and bolts. So to find the relative mass of something, anything, of 4 or 5 different things, we've got to find the smallest uh, mass, least dense, whatever you want to call it, item we're talking about. In this one, we're looking at the smallest. It's got to be the washer at 1.74. So that's what I'm going to base all these relative masses on, okay? And my calculation I use for that, I'm going to show them down here. I'll take 1.74 grams for the washer. I'm going to put a W there. Then I'm going to divide through by the mass of the least one, which is, well, the washer, 1.74 grams. If I divide that, so what does that mean? That means the mass relative to the least one, or the least component, is 1. So that means that the mass of the washer is 1 times the mass of the washer, 1.74. We'll write that there. Next one, we'll call that H, the hex nut. So the hex nut has a mass of 3.16 grams. To get the relative mass, I'm going to divide that 3.16 by the least mass of the least massive item. Of course, it's the washer. It's 1.74. So let's use our calculator. 3.16, go back over here. 3.16 divided by 1.74, I get 1.82. Call it 1.8. That's good. Or 1.82. Let's do 2 digits. Why not? So what does that mean? That means compared to the least one, the washer, that the hex nut is 1.82 times more massive. That's 1.82 times more mass. Okay. Now let's look at the anchor bolt. We'll use A for that. So the anchor bolts, this is a little bit heavier, 5.22 grams. Divide through by the least number, 1.74. Let's use our calculator. 5.22 divided by 1.74. Should see a pattern. I come up with 3. 0 there. So we'll call that relative mass of 3.00. So what does that mean? That means the mass of the anchor bolt is 3 times more massive than the least massive items. Okay? Okay, let's look at the bolt. So it has a mass, it's the most massive one, 7.64 grams. I'm going to divide through by the least massive item, 1.74 grams. So use our calculator, 7.64 divided by 1.74. And I come up with 4.39, 4.4, 4.39, something like that. We'll do 4.39. Again, what does that mean? That means that the bolt is 4.39 times greater 4.39 times greater than the least massive item, which was the washer. Okay? So what does that pertain to the periodic table and, well, chemistry for that matter? Let's look. So here's your periodic table right here. Okay. So in the 1800s, when they were working on this, they didn't have the instrumentation we have. What do they have? They had glassware and they had balances, like putting a weight on one end and the other. Okay. So they knew there was a difference between oxygen. If you recall from the Dalton's Playhouse in the previous unit, there was a difference between oxygen and hydrogen. They had different properties. Well, they looked at all these gases, right? All these gases, okay? Pretty much your gases, anything in red. And they knew that hydrogen was the least massive item there was, okay? So they took a known volume of hydrogen and in a piece of glass, and all it was hydrogen, and they weighed it, and they got a mass. Wrote it down, something like 1.74. Then they took a known volume of oxygen, the same volume as there was of the hydrogen, and they took a mass. And what they found was that the oxygen was 16 times greater than the same volume of hydrogen. So they looked at nitrogen, okay? And they took that same volume and they put it on the scale and they found that it was 14 times greater than the volume of hydrogen. Guess where we got these molar masses from? So you have the same volume of hydrogen, okay? That's the base. That's what we set everything on. Then we noticed the other gases were 14, whatever, times more massive than the same volume of hydrogen. So we use a relative mass, or they used a relative mass, to determine what the different masses of the gases are. Then, of course, they use other ways to determine the mass of the other ones. And we've got better instruments now. And they used to say that the number of atoms, okay, particles in one volume of hydrogen, okay, was what they based everything on. Now they called it a mole. Now we use the mass of 1 mole of carbon 12, okay, and we call it 12.12 as being the base for all the other atomic masses, or the molar masses, okay, which is what we need, all we need to know there. So anyway, hopefully that helps you understand a little bit about how to do relative mass and what it means. So anyway, this is Coach Scott saying good luck with all your exams, and hullabaloo, connect, hullabaloo, connect. All hail the Christian brothers, Purple Wave, and you guys know the rest of the song. Have a great evening.